Hey guys, welcome to Grad Coach TV, where we demystify and simplify the oftentimes confusing world of academic research. My name's David, and today I'm chatting to one of our trusted coaches, Alexandra, about 5 common mistakes students make during their quantitative research analysis. Today's discussion is based on one of the many articles over at the Grad Coach blog. So, if you'd like to find out more about quantitative research analysis, head over to gradcoach.com/blog. Also, if you're looking for a helping hand with your dissertation, thesis, or research project, be sure to check out our one-on-one private coaching service, where we hold your hand throughout the research process, step by step. For more information and to book a free consultation, head over to gradcoach.com. Hey Alexandra, welcome back to the Coachcast. It's really great to have you joining us again today.
Hey David, so happy to be here. Always fun chatting with you.
So Alexandra, today we're chatting about 5 of the common mistakes that students make during quantitative research analysis. And the first one comes up fairly frequently, and that's a lack of alignment between your golden thread and your analysis itself. What do I mean by a lack of alignment to the golden thread here?
Yes, so I feel like we've been talking about this concept of the golden thread a lot lately, but it really is useful, and you'll find it in kind of all programs, all walks of research. So in quantitative research and quantitative analysis, our core components of the golden thread rely on the research aim, the research objectives, and the research questions. Same thing for other kinds of research, but specifically in quantitative, if you have an analysis that you choose for your quantitative research that does not logically follow or logically answer those 3 aspects of the golden thread, it can reduce the impact of your analysis and results. And, worst case scenario, it can also kind of derail the full research project. Nobody wants that. It works hard enough to get to where you are. And so it's very important to make sure that those 3 fundamental aspects of your golden thread are justified, and they kind of set a precedent for the rest of your quantitative research, specifically analysis, that logically and suitably answers those 3.
I think that's really helpful. A good example of this would be a case where maybe you are suggesting you're going to be using a descriptive analysis, but if your research question is something about looking at the relationship between, let's say, HR practices and profitability in the UK retail sector, that's very suggestive of you're looking at a relationship, and that's again going to be an inferential study rather than a descriptive. And so taking that exploratory descriptive approach is not in alignment with what your aims and objectives are. And so we're really looking for a clear and uniform flow of information from your aims to your objectives to your methodology, and then right up to your analysis as well.
And also to that end, I think it's great to provide an example like that. I think we see HR a lot in the clients we work with at Grad Coach. And so another thing to kind of note is that it's important that this idea of the golden thread obviously is there from the beginning and throughout. So for instance, all of the stages of your research, such as your methodology, you can see aspects of the golden thread there of thinking about, does your sample, your research design, and your analysis, are they appropriate in terms of what you've set out to do in those aims and objectives? So methodology, we have to carry on the golden thread. When we're actually running the analysis, does the analysis method that you've chosen, is that providing the relevant answers or addressing those aspects of the 3 foundations of the golden thread? Is it answering the research question? And then even when you get to the writing process, when you're writing the results, you need to think about, have you clearly connected your findings back to your research questions and your hypotheses? Does it all kind of flow and make sense? And so I've said this kind of metaphor before, but if you think of like the domino effect, if you have all of your dominoes lined up, they'll knock each other down if they're in alignment. If one is a bit off or doesn't match with the other, they won't all connect. So the similar thing can be said for the golden thread with your quantitative research and analysis.
I think the domino effect is such a nice way of putting it. We've all seen those sort of crazy domino setups, and that's kind of the project. There's a lot of interconnected steps. And it's quite easy for that lack of alignment to sneak in. So a
Mm-hmm.
good rule of thumb to sort of check that your alignment is there is don't rely solely on yourself. Get a
Mm-hmm.
friend or a cohort member to take a look at your analysis and your aims and objectives and just check that there is alignment there. A
Mm-hmm.
good way to do this is get them to read it and ask them to give you the sort of key take homes or the elevator pitch of what you've presented. And if that's not aligning with your aims and objectives that you set out, that's suggestive that there's a problem and that you may need to go back to the drawing board to reassess and sort of recollate that alignment.
I think that's a really good example. And I think that it kind of goes against our instinct as researchers at the beginning, especially with quantitative, which has this, reputation for being so difficult and inaccessible to the, typical person. But that's actually all the more reason why you should have someone who's not in your program or in your field even, or in academia, look through this. If they're able to at least get the, the ground floor, let's say, understanding of what you're doing, then that probably means that for those who are, your markers, your colleagues, they'll probably understand it as well. So it is a great piece of advice.
So our second mistake that comes up quite frequently is using the incorrect data analysis test for the data that you have. Alexandra, why do we need to be thinking about what kind of data we have and the analysis test we run?
Sure. So kind of as we mentioned in the previous tip or mistake, is that it's so important that all of the different sections of your research align with the previous one, that notion of the golden thread that we talked about. And so specifically when it comes to the analysis portion, it's important to use the correct analysis for the type of data that you have, because this will impact your analysis. But in order to know what tests to use, you should have a good understanding of what type of data you have. So some of the common ones are categorical. This represents things like apples, pears. Then we have ordinal, and this is used for categories that have an inherent level to them, such as the Likert scale, strongly disagree, neutral, etc. And then finally, continuous data, things for height or weight, where there's always one that could be a little bit bigger, a little bit smaller. It's not so clear cut. So those are the three you need to consider.
So we understand that there are different types of data, but how does that relate to the analyses themselves?
Sure. So the first thing to consider when we get to the analyses, doing descriptive statistics. So why this data matters for the descriptive statistics, it is not appropriate to calculate means for all of the different kinds of data. Okay. For instance, it's not appropriate to calculate means for categorical variables, those things like apples, pears. Instead, for these categorical variables, think about presenting frequencies, percentages, modes. Okay. Going a little bit further, for ordinal data, that example with the Likert scale, data, for this kind of data, a mean is not appropriate. Instead, consider calculating a mode or a median.
I think following on from that, if you've got a continuous variable, let's say a construct like well-being, or maybe you've got a measure like height or weight, there a mean is totally appropriate. We're interested to know what the average of the population is. But finding out what the mode of a continuous variable, that's less helpful. We're not interested in how many times a specific height comes up in general.
Yes, absolutely. And so for descriptive statistics, it's important to know what kind of data you have. And for inferential statistics, this is no different, because your data determines what statistical tests you can conduct. But in order to know that, you need to consider some other following aspects. So first of all, your dependent variables, or DVs. You need to think about the number of DVs you have. What kind of data is it? Is it categorical, ordinal, continuous, dependent versus independent observations, normality? Going on to the independent variables, or IVs, think about how many, the number of IVs, type of IVs, levels of IVs. All of these you need to consider for DVs and IVs.
I think following on from that, the reason why we want to consider all of these factors is because each statistical test has certain assumptions behind it. I want to say the math behind the test. and it
Yeah.
requires specific things from the data. And so, for example, if you have data that is continuous and you've taken multiple measures of someone, maybe blood pressure over time,
Mm-hmm.
and you're
Mm-hmm.
looking at how that differs based on a treatment.
Mm-hmm.
To analyze that, we've then got continuous data that's dependent because you're taking multiple readings, and we're comparing that across a categorical variable. And that would then lead us towards a repeated measures ANOVA.
Mm-hmm.
Similarly, if you had a continuous set of data like height, and you had a categorical variable like gender or
Mm-hmm.
school,
Mm-hmm.
then you might be able to compare that with a standard ANOVA.
Mm-hmm.
Unless your data is not normal, then you'd have to do a Kruskal-Wallis. And
Mm-hmm.
it might seem like I'm throwing a lot of information out there, but don't worry about it. There are cheat sheets out there. There are tons of tutorials. And really, every test has a set of assumptions that you need to confirm you are meeting before you use them. So definitely take a look at how your data fits in.
Absolutely. And if I can kind of give another aside example, if you're using a survey, for instance, which are very popular these days in research, it's important first to not forget the importance of reliability assessments. So measuring for the Cronbach's alpha. If you are creating instruments in particular, you also need to assess the validity, potentially with a factor analysis. So that's another small point, but it has a lot of importance when you're doing statistics as well.
I think that's really helpful. And a bit of advice here as well is if at any point you're feeling a little bit uncertain, take a look at what previous research has done. If there are studies that are similar to yours, you can often get an idea of what tests might be appropriate based on what they've used. But that's not a silver bullet because you are going to have to still meet those assumptions. Again, if you're feeling uncomfortable with this or uncertain, feel free to reach out. Stats is not easy, and so it's really important to get help, get assistance. It's not something that comes naturally, and it's something most people have had to learn. I still need to go up and look most assumptions for a stats test up. So feel free to reach out. There are services out there, or in my case, I got through my PhD because of the postdoc in our lab that sort of helped me understand the stats I needed to run for my test. Our third mistake is one that we actually see come up quite often, and that's really overcomplicating the analysis. Alexandra, why is this something that we end up doing?
Well, that's a great mistake in the fact that it happens a lot. And I think that, part of what this video is about are kind of sharing these mistakes that people have gone through. I'm sure we've gone through these.
Oh, yeah.
So it can happen sometimes because as these entryway researchers, as graduate students working on our dissertations and theses, it's very common for us to feel like our research needs to be groundbreaking. It needs to be complex. It needs to put questions to all of the things that are in the world. And sometimes we feel that choosing an overly complex statistical technique somehow demonstrates our intelligence, when in reality, you're kind of just putting a block up for yourself and creating an obstacle that needn't be there. Because what you really should be focusing on is making sure that the statistical technique that you choose fits what it is that you're trying to collect in terms of the data, how you're measuring it. And that all goes back to the aims and objectives that we talked about in our first point. So it can be very easy to give in to that desire to kind of show off how smart we are or what amazing researchers we are. You don't have to prove that. What you can do is pick a statistical technique that actually fits what you need to do, and it does it well.
This is something that I actually had a lecturer drill into us. He sort of went with the mantra of take the simplest approach.
Yeah.
Don't overcomplicate it. Maybe you think, okay, let's use regression. Let's really find the predictors when honestly, we'd be better off doing a t-test just to compare two groups, right?
Absolutely.
The other thing to realize there is that the t-test has more statistical strength than a regression does. So you really don't want to be overcomplicating things where you don't need to.
Absolutely. And there's 2 points I'll add to that too, is to that end, sometimes I feel like regression, the research that I've been working with lately, regression is becoming increasingly popular. And so again, really don't do something just because it seems cool or relevant or other people are doing it. Fit your data. And so this kind of marries really well into my point of actually, if you're thinking about the marking that you're going to get for your research, oftentimes, and I would say most of the time, you will get graded higher and marked higher for choosing a quote unquote simple test done clearly and effectively versus an overly complicated a statistical test done poorly. Because what your supervisors and your committee really want to see is that you can make these research decisions that are applicable, suitable, and justifiable, and that makes sense. That's really the priority.
I think that's such a cool point, and it's something that even affects, really experienced researchers. They will submit a paper with a really intense statistical method, and the first referee that they get back, their initial comment is almost always, why did you choose this specific statistical test? And I could say it's something I've experienced myself as well.
Absolutely. So this blends really well into kind of something similar related to variables. So sometimes, in addition to selecting an overly complicated statistical test, I don't know what it is, what causes it, but we feel like maybe we need to incorporate or integrate more variables into our research. Something interests us, or we see that something else may have a cool finding, and so we think, oh, I'm going to sneak that variable in there, but in reality you're just shooting yourself in the foot, because adding these additional variables oftentimes can lead to more variation. It can mess up your results. It can stop this kind of cohesiveness with your golden thread that we've been talking about. However, that's not to say a big full stop of doing that. If adding a variable makes sense, you can justify it, it still fits with what you have set out to do, then that's okay. But just adding variables for the sake of adding variables, you kind of want to stop yourself from doing that before you get too far ahead.
I think that's really good advice, because it's so easy to get caught going down those rabbit holes because it's interesting and there's potential for significance, but really we want to avoid that wherever possible. Again, and we probably sound like we're broken phones here, but definitely stick to that golden thread, because a paper that's done clearly and explicitly that answers a research question is always going to be more impactful than one that is trying to do too much. So our fourth mistake that often comes up is not cleaning your data or checking the assumptions. What is data cleaning and why is it important, Alexandra?
Definitely. So I'll start with kind of this point saying congratulations, because you've collected your data. That's one of the biggest hurdles to overcome. So
Definitely.
with that in mind, once you actually have started looking at the raw data, it's very important to clean the data. So what you're doing here is looking for missing data, outliers, anything that seems a little bit off. This reason why we do this, clean the data and check for these outliers, we want to prepare the data for actually doing the analysis. And so in order to do the analysis, the data needs to be in a certain shape, order, and everything organized correctly in order to do the analysis. And so one of the things that you want to do when you're keeping an eye out for these outliers is to make sure that you have found them and that you are able to kind of see maybe something's wrong with them, because I know that sometimes they could lead to really weird or strange results.
Oh yeah, I totally have an anecdote for that. So even in my graduate studies, I was doing a study that involved assessing the ranges of birds. And I thought everything was great. I sent off my draft to my supervisor. They took a look at my data and said, hang on, one of these bird species has a distribution range the size of the solar system. That's not feasible. And it was at that point that I realized that actually in my data set, I had just had a minor miscalculation. But had we not checked the data, that would have had quite in-depth effects on our results. So it's super important to do the data cleaning, do the data checking, because your analysis is only as strong as the data underpinning it. So definitely put the effort in. It can be a bit of a slog, but definitely worth it.
Yeah, and to that notion of being a slog, it is tedious to clean the data, but it is important, especially if you're using programs such as SPSS, who are not really going to give you the benefit of the doubt if you have missing data or data that is off. Oftentimes it won't incorporate it, won't integrate it. It is a very fickle software. It wants what it wants the way it wants it. And so a way that you can avoid these kinds of negative consequences are to ensure that your data is clean, you've checked that there isn't any missing data, there's no outliers. And so I think that there are some ways that you can ensure even before doing this also that maybe there might be something off in terms of like doing a visualization.
Yeah, visualizations are super key. It's so important to actually engage with your data before you even hit that, run the statistics button in your SPSS. The important thing is you want to start looking at graphs, take a look at how your variables interact. And first and foremost, it's going to definitely help you identify outliers. I would have noticed that one bird species was a solar system large in their range had I visualized my data. But then secondly, it also allows you to start identifying patterns in your data. So you might actually be able to, when graphing your data, see that there is a difference between groups. And that would be suggestive that maybe a t-test will help you to identify that difference. So there's valuable insights to get from visualizing your data before just taking your data and jumping straight to the stats. So our fifth and final mistake is a big one. It's a pet peeve of mine, but that's chasing a significant result. What does it mean to chase significant results, Alexandra, and why is it such a problem in academia?
Sure. So nobody, if we're being honest, nobody intends to underdo a study that in the end will have not statistically significant results. It's a letdown. And so if anything, we want to prove that our study has significance statistically that somehow can correlate to I'm a good researcher and this study is excellent. So it can be very easy and tempting, and we've all done it, to want to chase a statistical significance for our study because we want to show that our study has meaning, a strong meaning, important meaning, its contribution. We'll hear sometimes people saying that they wanted to prove something, they equate that to significance. And so we can understand that it can be very tempting to chase this significance, but you need to slow down that strong desire of needing to only do something if it's going to be significant, because there are some examples where things that have not been statistically significant are also very interesting.
I think I've got a really great anecdote about that. Someone from my cohort doing their PhD actually found they were doing a genetic study and almost nothing worked. The systems that they were running weren't working. The analyses didn't come out right. And you might think, okay, this person is heading for a failing. But they actually ended up with a distinction because how they dealt with those issues really showed their capacity as a researcher. So they went through why they might not have found significance and really dug into the literature there. And so thinking that non-significance means a bad study is really not something to think about. It's not the main goal of what we want to be doing with research.
Yeah, definitely. And I think that another reason why this kind of desire for significance is perpetuated is that in the journals, in academic journals, oftentimes non-significant results are not published. And so it can be very easy to think, well, non-significant means not worthy of my time, not worthy of me. I'm not a worthy researcher. And that's not true at all. But it is easy. We can acknowledge that it is easy to feel that pressure to shoot for significance when the things that we're seeing around us in the dissertations we've read, in the studies we're reading, all say significant, significant, significant. We can understand that, but it's important to just quiet that voice.
I think that's definitely something that we see coming across, and it's why they've even set up effect size measures, specific statistical tests to actually determine how strong that significance is. This is also something that comes up a lot with the dreaded regression as well.
Yeah, absolutely. And I think that if I can go back to my emphasis again, let's imagine that you do not find statistical significance. Your results are non-significant. You can still, you had that great example from the person from your cohort, you can still present data or results, that are non-significant very cleanly, effectively. You can explain why there might not have been significance, why this is interesting that there hasn't been significance. And so I think that it seems we need to get out of this idea that significance is the priority. It's great, but non-significance can also be very interesting and lead to further very important research.
Such great advice there, Alexandra, and I'm so glad you joined us today for the Coachcast. It's been really great having you here with us.
Always great to see you, David. Happy to do it.
All right, so that pretty much wraps up this episode of Grad Coach TV. Remember, for more information about quantitative research analysis, be sure to head over to the blog at gradcoach.com/blog. There you can also get access to our free dissertation and thesis writing mini course that gives you all the information you need to get started on your research journey. Then don't forget, if you're looking for a helping hand with your dissertation, thesis, or research project, be sure to check out our one-on-one private coaching service where you can work with one of our friendly coaches, just like Alexandra. For all the information and to book a free consultation, head over to gradcoach.com. Well, that's it for this episode of Grad Coach TV. Until next time, good luck.